Okay, 4:10, bruh. I'm gonna die tomorrow. I have a freaking 8 hour of thinking of job. Yes, 8 hour of job tomorrow. Well, whatever. Okay, anyway, I cannot write this question in. I thought through it first lah. So I think I have a solution. Let me just run through my video. Okay, so give me a moment. So basically, right, let's read the question together. Given n nodes labeled, okay, just n nodes, right? Key thing is undirected edges. So each, whatever edge you see here can be pointing to each other, right? A function to check whether these edges may have valid tree. So right, let's draw a tree and let's plot a pattern. Valid tree, right? Invalid tree, right? Invalid tree, you know? So, I mean, what's the pattern? It's a loop lah, right? Yeah, it's just a loop lah. And then, okay, I'm pretty sure it's not called a loop lah, but yeah, it's just one of these things where like they point to each other. So let's say it's a correct tree, right? You have one, you start off, all these are included, you know, you mark these are included, and these are included, and these are included, and let's say the last one you check is this, right? You will realize that both these nodes are already included or so-called checked, right? Or even if you don't do this first, right, and you do this last, or any one of this loop edges last, right, it will point to say that both of these are actually already in the checklist. So that is gonna be my terminating condition, that both of these nodes and the edges are already in the checklist. So let's just initialize the checklist first, right? And then for I think it's actually a set, because yeah, I'm gonna add it multiple times, right? And say for edge in edges, right? So edges is here, for one edge is this, right? I will check for add edge 0, and edge is like the append of set, not really, but you can think of it that way. Don't actually me in the comments, you know, just like it's kind of similar. Okay, anyway, we add those. Oh yeah, so if edge 0 in check and edge 1 in checked, return false, right? And then otherwise return true. Haha, circular loop thing in graph. I call it graph because once you connect that, it's not a tree anymore, right? Yeah, so is it just like that? Oh, what the heck? So I'm thinking wrong. Can I pause this? I can't. Zero, 1, 2, 3. Oh, that's another requirement. You cannot be disconnected, is it? Now how do I solve that? How do I solve that they're not connected? Oh. Or maybe there's just a better way to solve this, and my way is not right. Okay, let's pause. Okay, pause. Okay, this is quite funny. So the first time I solved it, right, I actually got lucky. Like, I mean it's 4:36 a.m. so forgive me, but I thought I spotted some pattern, and I was like, oh, I finished it. Then I tried to explain it to myself, and it didn't work. Okay, but anyway, yeah, after trying a couple of times, I got it. So this is the edge case lah, right? If it's nothing, just return first, because empty tree is a tree. And then okay, so if anything loops back to itself, right, immediately we don't want it, right? So if it loops back to itself, because one end of the edge is the same as the other end, that means you're getting like whatever this node is, right? You point back to itself. This is not a tree at all. You can draw whatever you want after that. It's still not a tree. Yeah. So you don't want that. Then after that, you initialize a check set, and you check for edges. If there are any edges, return false. And then after that, this comes the part. Okay. So let's say you are given like n number amount of nodes, right? 1, 2, 3, 4. So the minimum number of lines you need, you are gonna draw to not connect them, it's like that, right? Let's say n equals 5 now. Whatever line you draw from this point on, right, you will either get a loop or a satisfactory. So this is a loop. You're gonna connect 0 to 2. But I already checked that already. And this will return false. So the only other possible is everything else that does not make a loop, which makes it a possible tree, which is one less than the number of nodes lah. I mean, right? If you have 2 nodes, you need 1 to connect. If you have 3 nodes, you need 2 to connect. So on and so forth. It cannot make sense. Like 2 people hold 1 rope, they are connected. 3 people hold 2 ropes, they are connected, kind of thing. So they just return. If this is true, return. If it's not, that means there's less, right? That means it will look like that. It cannot look like that because it will really be picked up by the circular edge detector, right? Or something like that lah. like 4 is on its own. So not enough edges mah. So this is just an easy way to calculate using n, which they so nicely provided you, right? You know, then you solve the problem. Finish.